Good evening. I'm Pierre-Gilles Mialon, and I'm here to share what the most important description came with Kubernetes. Nearly 20 years ago, I started working for the web industry as sysnet admin. At those times, sysnet admin was a nice word. It meant you rocked both the network and the system, or at least tried to. Now I prefer web architect or cloud experts. First, I was as head of hosting at NetActive. Linagora bought NetActive in 2008, and I became the head of hosting for Linagora Group. I left my 400 beloved customers to retire with a single final customers, Yakaz, an ad search engine. In 2014, Google decided that vertical search engines weren't useful anymore, so it reduced traffic to 1/4. Then I helped Radio France to migrate their web service from bare metal to VM, and then from VM to Kubernetes. Now I help Blablacar in their cloud migration. Okay, it's your turn to introduce yourself. Because of time, I propose to ask you a few questions. Please raise your hand if your answer is yes. First, who knows what a Kubernetes pod is? Okay, for the few that didn't raise a hand, a pod is a group of one or more containers with shared storage and network, and a specification for how to run the container. Who knows what a Kubernetes deployment is? Okay, a deployment declares the state of a set of pods running a stateless workload. Who knows what an headless service is? A standard Kubernetes service creates an IP and will load balance the traffic on pods. Sometimes you don't want or you need to access directly to the pod without the IP, so you can create an headless service that will expose direct IP. Who knows what a Kubernetes endpoint is? But endpoints are a real target of service for Kubernetes. They are updated whenever a set of pods change. But in some rare use case, you want to address through services that don't have pods. For example, you want to have a service in Kubernetes that have to reach external endpoint of your Kubernetes cluster. So in this case, you declare the IPs directly into the Kubernetes endpoints. Who knows what a pod disruption budget is? Okay, I will introduce this subject later in my presentation. To finish, are you a smart-looking dev? Who are smart-looking dev? No developers? Okay. Who are an ugly ops? Yes. Who are undefined DevOps? Who didn't raise their hand? Where are you there today? Let's start with cool people. Is Kubernetes cool for developers? Yes, it is. But why? Because everybody says so. For those who are using Kubernetes, is it cool? Yeah, very cool. So yes, first reason Kubernetes is cool because cool users of Kubernetes think it's cool. Second reason, Docker is so cool. But why? Docker will ship your code as a dependency as an artifact. You can keep track of version. It's easy to share. You just have to give the image, the address of the image with the right version to your teammates. It's great for portability. You can work on Mac, on Linux, even on Windows. It will behave the same as in your production environment. It grants isolation. So cool. With Docker, you can set up proof of concept in a minute and validate them in production 2 seconds later. I'm joking. But since you are using containers that start in few seconds, your deployment in production will be faster than in a VM-based cloud. With Kubernetes, your workloads are defined as code. So it gives you the ability to replicate, to iterate faster, to define advanced continuous deployment workflows. Kubernetes provides a unique interface with its API for logs, metrics, alerts, so you have the power. Kubernetes defines fine-grained permission with airbag, role-based access control. With those permissions, each of you can access only what they need. They are not lost in the wild. As I said earlier, your workloads are defined as code, so you can copy-paste almost everything. I think I didn't need to teach that to the generation that uses Wikipedia to do their homework. Yes, you can duplicate. And in case of trouble, before sending a Slack message to your infrastructure team, perhaps read your application logs. Kubernetes will give you the ownership of your services. Since they have simple access to their workload, to the observability stack, they are in position to operate their code in production and to be on call. So developers' teams can iterate faster without slow interaction with other teams. Less frustration, more ownership, more speed, more pleasure. You build it, you run it, and hopefully it will be the end of the ops problem. Okay, Kubernetes seems pretty cool for developers. Is it cool for their friends' ops too? Once again, everybody says so. Because Kubernetes provides a great network abstraction with features like load balancing, service discovery, network isolation, network security with fine-grained permission. Kubernetes also provides the auto-scaling features that permit to adapt the resource allocation to the traffic within few seconds. The provisioning and the resource attribution that is tedious work with microservices architecture disappear. Better resource allocation with more efficiency will result to reduce costs. To finish, Kubernetes provides a great way to deal with storage. It became easy to attach disks and containers at scale. Cool, cool, cool. Kubernetes is cool for developers, is cool for ops. It seems there's a kind of magic in it. So is it the land of ponies, the place where developers and operators can share mojito in a swimming pool together? Let us be serious for a moment. Imagine your code is a really smart-looking rabbit. As always, your code is perfect. Your code is peaceful because it is flower-powered, but put in production, and it will be lost behind the code of the other team. Kubernetes is not smart by itself. It does what you ask for, no more, no less. If you define nothing to protect your rabbit, the issue will be fatal. Your rabbit will be killed, and it didn't deserve it. I know I should have a warning for the sensitive soul, but sometimes the life is cruel. Now you have a question. Who is a nasty guy who kills a kind rabbit? Is this guy Kubernetes? Is this guy a member of the infrastructure team, the one who never talk, only to blame? Not really. This can be a human error. Cluster administrator deletes the VM by mistake, shoot. This can be a cluster operation, draining a node for repair, upgrade, or fix a security issue, draining a node for scaling up or down. So cluster operations are killing rabbits, and sadly, everybody have to deal with that. Other reasons of death are a hardware failure, a failure of the cloud provider, a kernel panic, a network partition of the cluster. The rabbit can be killed due to a node being out of resources. So a Kubernetes cluster is a disruption by design. You have to deal with. If you want peace, prepare for war. But our rabbit can be secured in a not so cool place like a Kubernetes cluster. First, you have to choose the right type of objects. Please never use low-level objects directly, like pods or replica sets. The big picture is the following. Deployments are for stateless services, workers, website front. Stateful sets are commonly used for stateful services like database, buses, replicated storage. Cron jobs are for cron, when you want to schedule a repetitive task. Behind the deployment or the stateful set, you want to expose a service. This will be the only entry for other workload to find the pod of your deployments. When your pod is launched, you have to check its status. Two types of check exists. The liveness. If it fails, the container will be restarted. The readiness. If it fails, the pod becomes not ready and the service stops sending traffic to this pod. The liveness here is here to deal with when in doubt, reboot. For the readiness, it could be different. Sometimes application can have temporary spikes. In those cases, stop traffic will permit to recover faster while the cluster is scaling. You should define requests for both CPU and RAM. The requests for both CPU and RAM are only used during the scheduling of your pod. Kubernetes will search a node that fits the amount of CPU and RAM you declare as a request. Try to declare a value that represents the high common use for your containers. You will have to iterate to find the correct value for most of your workload. Observe and adapt. This is the right way to do. For the limits, the behavior is completely different for RAM and CPU. If your container reaches the limit of RAM, it will be killed immediately. If your container uses a memory capacity bigger than the request, but less than the limits, and the node is under memory pressure, your pod could be killed. For the CPU limits, things are different. Your pod will never be killed because of CPU usage. But if you approach the limits, your process will be throttled. The throttling is like something really, really, really slow. My advice is to use CPU limit as a protection against fork bomb-like process. You can set it very, very high just to ensure that a process that didn't behave the right thing don't block other process on the host. To sum up, penalty for RAM overuse is death. Penalty for CPU overuse is slowness. Now, if you want to have a snap, it's the right moment, the most boring slide ever. You know that sometimes pod dies for the good reason, like a security fix. But when Kubernetes kills pod, it can be nice. First, we start a pod. Optionally, launch init containers. They can do work like fixing permission on a file system before the container starts. Kubernetes will wait until the init container exits before starting containers. If you have multiple containers, they will be launched together. If you have a race condition between container start, you have to deal with it in the container entry point. Optionally, Kubernetes can launch post-start script. There is no guarantee that they are launched after or before the container entry point. Now the container runs, everything is OK, but you want or Kubernetes need to stop the pod. The order to stop is launched in Kubernetes. The container is immediately set as terminating, is stop receiving new traffic. For example, your container is Nginx. Kubernetes will send a seek term to Nginx. Nginx will operate a quick exit. This is the normal behavior of Nginx when it took a seek term. That means it will drop all connection immediately. If the process doesn't exit, in 30 seconds by default, Nginx will receive a seek kill, and this is the end of the story. But optionally, if you declare a pre-stop script, you can send Nginx squit before Kubernetes sends seek term. In this case, Nginx will finish the connection and exit at the end, and this way you will be kind and exit gracefully. You have to define running update strategy. You have two parameters you can deal with. They could be integer or persons, max and available, which define how many pods you accept to lose during the upgrade. Max surge, that will define the number of pods that the scheduler will launch at once. And all pod will be replaced only if the new pod is alive and ready. As I said earlier, there is no magic in Kubernetes scheduler. For this reason, you want to have affinity and anti-affinity. For example, you have deployment that runs on 3 pods, you want to add a node repulsion between those pods. Eventually, if you are running on a multi-zone Kubernetes cluster, you want to add zone repulsion too, to ensure that pod will not be scheduled on the same host or the same region. Sometimes you want to collocate on the same node deployments that will call each other frequently. Affinity is the right tool for that. There are two ways to define affinity and anti-affinity, preferred or requested. My advice, preferred is often the best choice. Requested can start new node or block the schedule of your pod, for example, during scaling of the deployment. One of the most interesting features of Kubernetes is its ability to scale. When you create a deployment, create the associated horizontal pod autoscaler, or HPA. Kubernetes lets you scale on CPU, RAM, or custom metrics. Imagine you can scale your workers with the number of messages in a bus queue. It's beautiful. You can scale your Nginx on the number of connections or requests, or both. So during the scale-up, if you declare a requested anti-affinity on zone and you already have a pod in every zone, then the deployment will never scale up. Last but not least, the pod disruption budget. A PDB limits the number of pods of a replicated application that are done simultaneously from voluntary disruption. For example, a quorum-based application would like to ensure the number of replica is never brought below the number needed for a quorum. A web frontend might want to ensure that the number of replicas serving load never failed below a certain percentage of the total. Still, you have to be aware that a bad setup on PDB can stop a cluster update. Thank you for your attention.
Thank you very much, Pierre-Gilles. If you have any question, feel free to raise your hand and we will send you the catch box. Yes.
What would be the...
Can you speak in the mic, please? Oh.
Ah.
Technology.
What do you think would be the best size for a team to use Kubernetes? From which size does it becomes interesting for a team?
Any size, I think.
Okay.
It's really nice. I host websites for 20 years, and it's the greatest thing that ever happened. I spend time racking disk in servers with this kind of things. It's never happened again.
Thanks. We can do still 2 more questions. Anyone?
Hello. I have a question that you might have come across. How would you propose to manage the shutdown, a graceful shutdown of a pod with a container and a sidecar, where you want the sidecar to end after the main container is shut down? I want, for instance, I have a sidecar that's shipping logs.
You share a volume, and you put and you write a
PID file.
A lock, and you ensure on both containers you ensure that the lock has disappeared before shutting down the second one. So you with a pre-stop script. At the beginning, when you start your containers, you create the lock. And after, before killing, you have the containers that should die the first. Mm-hmm. This one remove the lock, and the other one will never stop if the lock still exists.
Okay.
I'm really new to Kubernetes, so it was just like having a a newbie definition of what is Kubernetes, and in my understanding, it's like used to help web-based application run smoothly and optimize the cloud resource consumption, something like this.
Yes. Yes, it's not only for web-based application. You can do everything with Kubernetes. The object of Kubernetes is running containers at scale. It's a way to. 20 years ago, we were trying to launch process and to ensure that the process were running. Kubernetes continue to do exactly the same thing, but with other tools, and we can leverage a lot of issue with the hardware stability. The idea is you can increase your reliability because you have a lot of servers, you can have multiple dredging, and you didn't see your process like something on a single host that run just in parts that can be cut.
There's two things I understood. One is it helped developers to push to production and version their codes. And the second one is really the load balancing and cloud resource optimization. So it makes both.
Yes, it makes both.
Okay, sorry, very newbie question. I'm sorry, but
you will have time to ask questions afterward if you need. Thank you very much, Pierre-Gilles. A big round of applause, please.
Merci.